Welcome and thank you for joining our webinar today, How to Attack a Linux System, plus How to Detect and Respond Swiftly, featuring guest speaker, Unix Linux expert and CTO of InGuardians, Mr. Jay Beale. You are also joined by Rod Simmons of Beyond Trust, who will cover a few points about Beyond Trust PowerBroker Server Suite solution after Jay's portion, so please stick around for that. My name is Sarah, your webinar host today. Hello, everybody. A kind reminder to please submit your questions via the GoToWebinar console anytime throughout the webinar, and we'll cover your questions at the end during our Q&A time. Also, today's session is being recorded. You'll receive a follow-up email containing links to the recording and the slides shown here today within 1 to 2 business days from now. The slides can also be immediately downloaded via the handout section in the GoToWebinar console. Additionally, if you are attending for CPE credits with ISACA, you can locate and download the attendance verification document from the handout section now. Okay, phew, now that that's all out of the way, let's hand it on over to Jay, who's going to jump right in. And Jay, hey, welcome aboard.
Hi, thanks, Sarah. I appreciate it. Hello, my name's Jay Beale, and you've heard our talk title. Our talk title. This is my bio. It's a sea of text, and so we'll skip right past it. So here's what we're going to do today. I'm going to do attack and defense. I love doing attack and defense demo style. So I'm basically going to show you how to attack a Linux system and then how to detect that attack and respond to that attack automatically, faster than you could do as a human with OSSec. And then we'll also be talking over other proactive security measures you could take. The cool thing about the way I do this is you can get the virtual machines that I'm working with here. So we're going to use Kali Linux, and that's easy to download and install as a virtual machine. And then the other virtual machine is, in this case, the Mr. Robot virtual machine. You can find it on VulnHub. And what I like to do with these is sometimes I build my own virtual machines. Sometimes I download these others, but the idea behind the VMs is they're capture the flag VMs. And so it's like a one-person capture the flag, where you hit you launch the VM, you find its web server, you bring up the web server and look at what the game is you're trying to play. And that game generally involves trying to get 3 flags, sometimes more, and the last flag is almost always root. And I love these things. I play them, and when I'm done playing them, I think, like, wait, that attack would have been pretty easy to break with some proactive hardening or with some free tools. Let's see what we can do. And I like to do videos like this and talks and blog posts and so on. So without further ado, let's get into it. So my next slide is going to be the what happened. So we're now in demo for the bulk of this talk. So I like to record all my demos because the demo gods are all descended directly from Loki, and thus they are tricksters. If you don't record your demos, at least in my world, something will go wrong. So what I'm going to do is basically show you the attack and then the defense on this Mr. Robot VM. So what you're looking at right now is is a recording, of course, but it's my Kali Linux desktop, and I'm going to start off by going and looking at the Mr. Robot machine. I put Mr. Robot in my etc hosts file, and so you hit this, and it looks like a Linux system booting. And now it looks like someone's logging in. This isn't me typing. This is all basically the video recording that comes with this Mr. Robot VM. And these capture the flag VMs you can get from VulnHub, they're really fun, especially because someone's gotten really creative with them. So this is where the video ends, and I chose one of the commands to run. And when you run one of those commands, it shows you a video. And I'll let you download the Mr. Robot VM and take a look at the other commands you could run. What I did was I said, okay, I went through each of those commands, and none of them gave me anything all that useful. They were really fun TV show tie-ins. So I did one of the first things I do anytime I'm trying to hack a web app, and I basically say, okay, let me look at the robots.txt file. And that robots.txt file it's a file, it's a convention that's been created that basically tells the web crawlers, things like the Google web crawler and the Yahoo web crawler, could you just not list these in the search results? Would really appreciate it. It's kind of, these are embarrassing things, or they're things that, that's really, we have to keep world accessible, but we don't really want crawled. And so if you, as an attacker, you go and look at robots.txt, and so I've pulled up robots.txt, and I see that there are two files. One is this fsociety.dic. The F society is misspelled, but that's what the creator did. And I can pull that file down, and so I'll pull it down. And the other file is key 1 of 3, and this means this is the first flag. So you're going to see us basically get each of the flags in this one-person CTF. So this is kind of your first flag. So you're going for 3 flags. Anytime you get a flag, it means you're doing pretty well. So that fsociety.dic, I also downloaded robots.txt, but that fsociety.dic, I can open it up, and it's basically a word list, and that word list will be really, useful to us. When you're hacking a web app, if you run into authentication, what you do is you basically, you try all of the, as passwords, you try, all the things that are in a dictionary. But often you'll build a dictionary that has, say, all the words on the client or on the target's website, and the reason for that is that those will be proper nouns. They'll be terms of art. They'll be things that people might choose their passwords based on. They're not really good. It's not a really good idea, but that might get you your usernames or passwords. So we're going to take that dictionary file and save it for later. And the next thing that I'll do with one of these, with any of these capture the flag VMs. Actually, I'll pause for a second and take that fsociety.dic and look at how many lines are in it. So that was a 858,000 line file. That's a whole lot. Maybe there's some duplicates. So I'll take that and I'll cat it into sort and unique, and make a version of that file that's, fsociety.dic.unique, and then I'll look at the number of lines in that. And let's see how many unique things there were. Okay, 11,000. So that's much, much better. Okay, so I know I'm going to use that later on. And so now I'm going to move to the next thing I'll do on any of these capture the flag ones that involve a web app, and I'll fire up Dirbuster. And what Dirbuster does is you give it a URL, and you give it a list of file paths and directories that are commonly found. And basically Dirbuster will go and look for all of those. It'll look for, things like, status.php or log.php or /logs or what have you, things that will be useful to an attacker. It's basically going to find you some, what we call in the pen test world or in the red team world, attack surface. And so the way you set this up, you start up with Dirbuster. The reason I'm using Kali is because it's got all these tools. Installed and set up already. And on Kali, if you go into user share, every one of those tools gets its own directory. So I'm going into user share Dirbuster, and that'll be the files that, if you clone Dirbuster on GitHub, that'll be the other files that were there besides just the binary ones, besides just the programs. So we go into user share Dirbuster, and we find a word list. And this word list is basically a list of the kinds of directories and files that we can say, Dirbuster, go, basically just request all of these, try these and see if we find anything useful. So we're going to choose a medium-sized directory list, all in lowercase, and we'll kick up the number of threads, it's basically going to span 15 copies of itself. And if you look at this, as this thing's running, it basically says it's doing something along the lines of 153 requests per second, now down to 90, now 134 requests per second. It's just it's asking for all of these things. So in the short time we've been running already, it's gotten to, a good 2,600 requests so far. Now I'll tell you, there are a few points in this video where I've edited it to skip past and advance us forward in time just to save us some time. But what I did is, as I was watching all these run, was I sorted everything by found. And what I found is the Mr. Robot VM is using WordPress. And so I'm going to take a look at that WordPress login page. So let's go and check that out. So I'll close some windows, do a little cleaning up, go into my VM, and let's take a look. We saw we had those fancy videos and all that, but underlying it is just a standard good old WordPress. So I'm going to try user password. And the reason I'm going to do that is to see if this happens. I want to see if WordPress will tell me if I've got, if it'll say whether my username was wrong or whether my password was wrong. Now, it's awesome when any application tells you that your username is wrong. It doesn't just say your credentials must have been wrong, because that means you can guess at usernames. And if you can guess at usernames, think about it this way: if you can guess at usernames, if it's gonna take 1,000 username guesses to get one that's right, and then 1,000 password guesses to get one that's right, if you can separate those two steps, you're gonna do 2,000 guesses. If you have to try every one of your 1,000 username possibilities with every one of your 1,000 password possibilities, then instead of 2,000 total, it's 1,000,000 total. And the more, so it's instead of 2 times X, it's X squared. So you get the sense really quickly that it's wonderful. I remember writing back in the early days to the Netflix, I think it was to their CIO back at the time, and saying, "Hey, by the way, I noticed that that you tell me when my username's wrong. That's not helpful. Or that's helpful. That'd be helpful if I was an attacker. Luckily, I'm just a user, but it'd be great if you fix this." So anyway, we're going to use that against us. We're going to use that against the WordPress page. So it says invalid username. Let's take a look at the page source and basically just find that login form. And that login form was wp-login.php. It's a post request. And so now what's the data for that post request? The username goes in log and the password goes in pwd. Okay, so we'll set up a tool. We'll set up wfuzz. And wfuzz it'll do anything you ask it to. It'll basically put input into a form. It's not just for authentication. And it'll tell you when it gets output different than what you were expecting when things aren't right or what have you. So we're going to say, hey, wfuzz, try this list of usernames that's in fsociety.dict.unique as the fuzz parameter, as log equals as the username, and you can use the same password. The password can be all J's, and just run. And similar to Durbuster, this is going to very, very quickly, it's going to make requests. It was set up to do 11,000 requests. It found a valid username within under 5,500 requests. It found Elliot. So Elliot, okay, cool. Elliot's the, kind of our main character, Mr. Robot. That seemed like we probably should have guessed that one, but it was more fun to automate it. So now let's put in Elliot and let's try a password. We'll try a password, and it says, now we get an error that says, hey, the password you entered for Elliot is incorrect. Cool, so Elliot's right, that password's wrong. Let's go and fire up wfuzz again, and we'll use that same dictionary. So we'll fire up wfuzz. We'll use that fsociety.dict, the sort and unique version of it. And now, instead of looking for something that differs from invalid username, we're looking for a time where we don't get back password you entered. And we'll set log equal to Elliot, so that's the username's Elliot, and we'll set pwd to that capital fuzz. Remember, this is wfuzz, we're fuzzing, so fuzz makes sense here. So Mr. Robot, wp-login.php, and we fire it off. And it's going to try a whole lot of possibilities. There are lots of other tools that would do this, but in this case, we're using wfuzz. I've advanced time just a little bit, but so it normally takes about 2 minutes, and we get Elliot's employee ID number at Evil Corp, ER280652. And so we've now got valid login credentials for Elliot into WordPress. And honestly, with WordPress, vulnerabilities are great, but we didn't need a vulnerability here. Well, it kind of was a vulnerability that it told us our username was wrong until we found the right one. But once we've got WordPress, we're basically able to put PHP on this server. So let's see what we do. So what I'm going to do is I'm going to replace the I'm going to replace a page. So I've gone into the editor. I'm going to click on the 404 template, the page that shows up whenever the page you request doesn't exist. And now I'm going to replace that 404 template with a PHP file. And I could use something created out of Metasploit. I could say, give me an interpreter in PHP or something like that. But what I wanted to do is show you that Kali's got web shells. So if you go into user share, remember that directory that's got all those tools, it's got a web shells directory, and the web shells directory has, web shells in a few languages, including, Perl, one of my favorites. But if we go into the PHP directory, we'll find there are a few web shells, and we'll pick one. And this is the PHP reverse shell. So this is a web shell that's going to basically, this is going to run, and it's going to connect back to our Kali system. We're going to have to edit the file and tell it what IP address our Kali system's at. But it's going to connect back to our Kali system, and then it's going to basically present us with a shell. Anything we type, it'll run on the system using PHP's code execution. So using code execution functions in PHP. So we'll open up. You might use gedit if you're a normal Kali. This is a lightweight Kali called LXDE that I use in my training classes because it leaves more processing power on the laptops for the VMs we're attacking and defending. So I'm going to set my IP address to 1023.58.30. That's the Kali machine's IP address, and the port to 4444, HD Moore's favorite port. You'll find that throughout Metasploit. We're not using Metasploit, but it's still a really popular port to use, 4.4s. So we replace that PHP file now, the original 404 page, with this web shell. And this web shell was written some 11 years ago by a guy who called himself Pentest Monkey. And I think many of us are very grateful to Pentest Monkey for creating that for us. Back in the day, we just all had to write our own. So we've got that set up. I'm going to set up and go into a new window, and I'm going to say on the Kali system, I'll set up Netcat to listen on TCP 4444. That's where the web shell is going to connect back to me. And now I'll start up a new tab, and I'll say, Mr. Robot, and now show me some page that doesn't exist so I can trigger the 404. So non-existent page. And here we go. So I've now got a shell on that Mr. Robot system. I'm running as user daemon. So that's not root. I'm going to want to get to root. I do an ls. Okay, I'm in the slash. So I'll go into home and see who's there. And who's there? There's a user there named Robot. Cool thing is, that robot user's home directory, there's a weak UMask on the system. So there's weak default permissions. So any user on the system can basically read the contents of anybody else's home directory and walk into it, unless those other people, manually change permissions. So as the attacker, I'll go and look in that directory, and I'm going to find two files. One is another flag, but I can't read that yet because that flag actually does have good permissions. It's only readable by robot. But the other is the robot user has gone and put an MD5 copy of his password in his home directory, and he forgot to make it not world readable. So we'll take that MD5, and this isn't Windows. We can't just take a hash and start passing it around. But what we can do is bring up a site that can reverse that hash for us, that basically has a list that either has a rainbow table of tons of passwords that might match a hash, or can run through lots of possibilities. So we put our hash in, and we hit enter, and it says it's gonna have a little delay just to stop people from abusing it. But what we get really quickly back is, hey, here's that password. That password is ABCD all the way through Z. And so now, being on the Mr. Robot system, let's switch user to Mr. Robot. So I try to run su robot, because that's going to let me go and say, I'm going to switch user to robot and type that password. It says it has to be run from a terminal. So I'll use an old pen tester, red teamer trick, and I'll write a little Python program that creates me that basically gets me spawns me a TTY or a PTY. So I'll import PTY and run PTY spawn. So I'm just writing a 2-line Python program. So this is import PTY, and that says PTY spawn and run bin bash on that. And I'm creating a program called /temp/shell.py. And if you're really watching your systems, me writing, Python programs to your temp directory might be noticeable and might be something you'd be looking for. So then when I run that program, I've now got a more meaningful shell. It's the same user, daemon at Linux, but now I'm going to do su robot, and I'll type my ABCD. Actually, I'm going to copy and paste because this is what we call enlightened laziness. It's when you do things. It's when you use automation or when you use copy paste and make your life more free from fat fingering or run faster, what have you. So I got my start as a Unix sysadmin, and we were always trying to automate ourselves out of a job. I think given the whole DevOps world, we may have we automated ourselves into a whole new kind of job. So here we go. I've got my next flag, and I want to clear my screen. I can't clear my screen, so I need to set my term variable. And I'm old school. I remember modems, so I'm going to set my term to VT100, which was always a good terminal emulator to use. And now what I'm going to do, so if I'm really doing this as capture the flag, I'm not going this fast. I promise. None of us are this fast. We don't our first guess doesn't work all the time. What happens is you basically try something, you try something else, and you try something else, and then you find something that works. And there are places where it's, yeah, I've done this 1,000 times, but there are lots of places where it's like, I don't know what's going to be wrong with this system. I don't know what configuration problems it's going to have. I have to go and look for them, which as a defender is the same kind of thing you're trying to do if you're hardening a system. So as an attacker, I'm going and looking for, what's done wrong here. So one of the things I'll do if I get a normal user on a system, if I've got a human user, like I've got this robot user now, is I'll basically say, okay, what setuid programs can I run? We've already run one. We ran the SU program, but what others? What other programs are here that let me run code temporarily as the root user? Whenever you run the password program to change your password, you're running a setuid program. And that setuid program, by the way, is one that you definitely shouldn't expect the web server should be able to run. We'll talk about that later. But we're going to go looking for setuid programs and see if there are any that are out of the ordinary. If there weren't, we might see if any had vulnerabilities, and if there still weren't, we'd just go looking for something else wrong on the system. So I've run a little find command, and I said, show me all the setuid programs. And all of these look pretty normal, except for this one here. Nmap is never setuid, but this one's setuid. So let's clear the screen and try running it and getting its version. So there's only one Nmap on the system, otherwise we really should use the full path. And it says it's Nmap 381, which is definitely a wonderfully early version, which means if I dig around a little bit in the man pages and so on, I find it's got an interactive mode. The cool thing about interactive mode, any setuid program out there, you got to make sure it doesn't have shell escapes. This one lets you run commands. So if I put an exclamation point and then type anything, that command's going to be run in a shell. And so here we are. I ran ID, and ID said your robot, but your effective user ID, this is what happens with setuid programs, your effective set user ID is 0, is root. Okay, so I can run things as root. Well, let's take a look at the sudoers file. So I'll say, just show me anything in the sudoers file that has all. Okay, so I could be running things as root if I just put robot into the admin group, maybe. I'm gonna make it a little bit easier on myself and just say, just trying to type this ABCD thing, this long password. I'll do robot, all equals all, and then no password. So the robot user can run any command he wants as root without having to type a password. Now that'll do. Okay, great. So now I'll exit that. And now I'll do sudo su. And here I am. I'm root, and let's look at the third flag. I've got the third flag. Now I've made things, I decided to add a little bit more onto this VM. I've created another VM. I've created a relationship between this Mr. Robot VM and another VM. There's an rsync that runs, and I've just I cut this video a little too tight there, so let's look at that. There's an rsync that runs. It's called synchronized to higher value machine, not to be too obvious about it. And so if I look at that synchronize, what it says is hey, look, there's a user called admin over at this machine that ends in .66. And I say, well, that sounds valuable. Let's go see what's over there. And so what I'm going to do is I'm going to fire up another tool. This one's called Hydra, except I'm going to use X Hydra, which is a GUI graphical user interface. And I'll set up that 66 as my target, and I'm going to tell it we're guessing passwords for SSH, and I'm going to give it a password list. So I'm going to tell it, hey, I already know the username, so that's going to be much faster that way. And now for password, I'm going to get something out of password list. And I could use my fssid.dic again, but let's go and just use kind of the file that's used on a Linux or Unix system for spell checking. So user share dict words. So user share dict. You know what? Instead of words, I'll use cracklib. And cracklib is half the size of words, and yet it has common passwords. So I'm not going to use every word that it knows in the English dictionary. I'm just going to use a set that's been really, really useful. I'll go and tune this. It's going to choose 16. It's going to try 16 attempts at once, and I'll hit start. And I have, again, this is trying a ton per second, and I've cut a little bit out, but it finished, if you look at the timings, it still finished in um, about 30 seconds. So in about 30 seconds, we got the right password. So we have admin and Abner. So our password's Abner. Okay, cool. This is what we call in the red teaming pen test world, we call this lateral movement. So we're going to move laterally over to a system, another system. It's got this user admin, and I'm going to type Abner, and now I'm on this system, and let's look around. So if I do an ls, I see this file called loot. Okay, it won't always be so obvious as to be loot.txt, but if I cat out loot.txt, I get maybe this is ASCII art. Let's zoom out. Oh, darn it. I cut my video a little tight. It was ASCII art. Here. There we go. So it's our InGuardians red team sticker that's been turned into ASCII art. So anyway, that's our attack. That's start to finish. That's basically starting out with a web server, finding out that it's running that even though it looks really fancy, it's just running WordPress. Realizing we can guess passwords on WordPress and so on, and making our way to root, and then making our way laterally to another system. So what I want to do now is show you a simple defense that you could use to break this attack and tons of others. And the reason I'm interested in this kind of thing is that I've been doing proactive defense for a long time. I've been writing tools like Bastille Linux and the original Center for Internet Security's, benchmark and scanning tool. I've been writing articles and teaching classes and all that on proactive defense for, well, a long time, almost 20 years. And and so often I see things happen like the Equifax hack or what have you, and I think, man, if you just set up some proactive defenses ahead of time, even though you had the vulnerabilities, you didn't have to get compromised by them. You're never going to know what code is vulnerable. You can patch so that once the vulnerabilities are publicly known and there are patches available, that you spend the least amount of time vulnerable. But it's really great if during that 0-day period where nobody even knows that there's a vulnerability, or even during that period when you're lagging on the patch, when you're not allowed to install the patch, you haven't had time to install the patch, it'd be really nice if you had some kind of mitigating defenses. And so I'm really a huge fan of anything you can do proactively. And one of the things we can do proactively, we can set up a system like OSSEC. So OSSEC, I've already copied the source code over, and so I'm going to run its install script. It's pretty fast. You uncompress the tarball, you run the install script. It says, do you want this to be a server to receive logs from lots of OSSEC systems? Do you want this to be an agent, to be a system that doesn't have a server on it, it just sends logs out? Or do you want to do hybrid or local? So we're going to choose local, which basically means stick it all in one box. We tell it where to put it. I'm going to turn off the email notification, but I think you should always use the email notification. Also, for the purpose of this demo, I'm going to turn off the integrity checking, the tripwire type daemon that's here. OS6 integrity checker isn't as good as tripwire or AID, the things that are just into file integrity checkers. But having it all in one tool is really nice. So I would normally leave that on. It says, do you want to have rootkit detection on? I would normally run that because it's actually really good. It's much better than check rootkit. The rootkit detection engine that comes with OSSEC is just great. So I normally leave it on, but just for our purposes of our demo, I'm not. And now the thing I'm trying to get at, which is, do you want active response? And I'll say, yes, I want active response. We'll say, do you want to whitelist any IP addresses? Is there anywhere you'd be coming from that you want to never be blocked by the firewall? And I won't add anything, but you probably should. You should add wherever you're going to admin from. And you hit enter and it compiles, and that compile happens really fast nowadays because of solid state drives. And so I've got this compiled, and now what I'm going to do is go and tell it to go and watch. This is on the Mr. Robot machine. So I'm going to go and tell it, Mr. Robot machine was built with a Bitnami machine, so its Apache log files in a strange place. So I'm going to go to the end of this and a file and basically tell it tell OSSEC where to find the Apache file. The next thing I'm going to do after that is basically this highlighted text here, the active response. We're going to come back and configure that. So we'll be coming back to this file later, but right now we're just going to add a local file. We're going to say start watching the Apache log, and the Apache log that WordPress is tied into. Basically, all the WordPress authentication errors are going to go to this Apache log. So go and watch this file, and the file location is, and this is the Bitnami specific part, opt Bitnami Apache 2 logs, access log. Whenever I'm watching one of the videos I've made, I always wish I could type faster. So I'll go into var OSSEC, and that's basically where all of OSSEC stuff is kept. Its config file, its rules, its decoders. And the way OSSEC works is it's basically a log-based intrusion detection system. And in this case, since it's active response, we'll even call it kind of an intrusion prevention. But and if we look at this decoder file, if we want to look for a specific, when we're running with OSSEC, we can set up OSSEC with its default stuff, and sometimes that's good enough. And here it's good enough. But if we wanted to do more, we might have to create a decoder if we want OSSEC to be able to watch for log files from a program that it doesn't already have a decoder for. And that decoder is something that basically knows how to say, these messages are for me. The program name is often what we're getting. And there'll be some regular expressions. So this decoder basically, there already is one for WordPress, and this one basically knows how to find WordPress things and knows how to find the IP address that's trying to make the connection. So we don't have to write our own decoder. So that means all we need to do is write a rule. The cool thing is OSSEC actually already has a rule for this. So we're going to go into this. We're going to go into the web application rules in OSSEC, and we'll find there's rule 31509. That sounds almost like a song lyric. And it's basically says, hey, this is a login attempt. So this is just a post request against WP login.php, that same thing that we've been doing. And the cool thing is 31510, the next rule says, hey, if 31509 fires enough times in a short enough time period, then it's probably a bot. It's probably not somebody trying to log in. It's probably someone trying to brute force. And so this rule fires if 31509 has fired a certain number of times in a certain time frame, and we can adjust the time and the time frame. But the important thing is basically that same source IP that you see right here in the middle. That same source IP says, hey, if we get this many requests during a short time period from the same source IP, then we're looking at an attack. So what I can do now is I can go into that original ossec.conf where the active response rules are. So I'm going to look for the active response, and there are two sections. There's a host.deny section for anything that's TCP that uses TCP wrappers, and then there's an actual firewall drop, and we're going to do both. So I'm going to go and basically take this. I'm going to say, hey, if 31510 fires, so rule ID, if 31510 fires, and you'd put any other rules in here that you want to result in a firewall block. If 31510 fires, then you're going to create a firewall rule for 600 seconds, okay, for 10 minutes. And then there's a cool thing we can do. Repeated offenders says, listen, after that, when the firewall rule goes away, if someone does that again from the same IP, we'll block them for an hour. And if they do it again from the same IP after we've unblocked that, we'll do it for a day. So this is a really cool thing. So I've done this, I've set this up for the host.deny. I'm going to copy this, and I'll go and do the same thing in the firewall section. So get rid of this level 6. That's basically saying any alert level 6 or higher should be firewall blocked, and that's a little aggressive. And I'm just going to replace it by just a single rule ID. And so now once I've set that up, I'm going to run OSSec control start and tell OSSec to start running and start watching the logs. So now it'll be watching logs, it'll be creating alerts, and if 31510 alerts, it'll create a firewall rule. And so now what I want to do is, okay, I am missing a step in my video, it looks like, but basically what happens here is once I do that and I fire if I go back and fire that Hydra rule, I'm sorry, the WFuzz off again from the Kali system. Kali system had .30. What happens is that that on the Mr. Robot VM, once a good number of requests have come through, and I think the point we saw it was somewhere around 90, is when WFuzz realized something was just badly wrong. What happens on the target system is that OSSec basically goes and creates a firewall rule saying, hey, you know what? We're just going to drop all packets from .30 from the Kali system. It seems like it's bad news. And at that point, our attacker's getting nowhere. So that's the end of the demo side. I'm just going to kind of take us back to the slides and talk about what happened in the attack and how the defense worked. And then I'm going to turn it over to our sponsors at Beyond Trust. So real quick, we went through, we found a Mr. Robot, capture the flag machine. We hit its web page, we played around with it, we looked at its robots.txt, and we found a dictionary of words that were specific to the organization or specific to the CTF. We ran Durbuster, and we found that there was a WordPress login page. We used WFuzz to find that valid username and then to find its password. We put a web shell in WordPress in place of the normal 404 page. And that got us a reverse shell. When we were on the reverse shell, we found the setuid program. We found nmap running as root, and so we used that, and we got to sudo-su. And then we found that there was some kind of cool intellectual property on another system, and so we used xhydra to guess passwords on the second system, and we SSH'd in, and we got to see our logo. So to block it, there are a bunch of things we could do, but in this case, we set up OSSec to detect the attack on the WordPress site, and we configured it to alert us and to deploy a firewall rule that was going to block that password guessing attack. And there are a few other places we could do that. We could actually, in another version of this demo I've given before, I've had OSSec running on the second system that blocked the SSH password attacks. We could do it there. What else could we do? We could use IP tables rate limiting, and that would make it so that you couldn't start that many fresh connections to a system that quickly, and that would slow down the password attack. And our whole goal is just to slow it down so that someone can't get enough requests through to guess the right password. What else could we do? We could strip setuid out of nmap, or we can make it at least so that nmap and maybe even su could only be used by, say, the human users on the system, but not by the daemon user, not by the one the web server was running as. And then the other thing we could do is we could use AppArmor or SE Linux and basically make it so that if you are able to put PHP pages on the WordPress site, you can make it so that those PHP pages can't just go and run arbitrary commands, even if WordPress was running as root. So that's pretty cool. That's what we can do. So to close out, You can find blog posts about stuff like this at InGuardians site. You can also find a whole bunch of webinars I've done with Beyond Trust that are similar to this on Beyond Trust site where you signed up for this. You can get the Mr. Robot Virtual Machine at VulnHub. You get Kali at the Kali site. You get OSSec at the OSSec website. And of course, you can attend one of my trainings at Black Hat or DEF CON. Happens every summer. So with that, well, now let's hear a word from our sponsors.
First of all, Jay, great job. Always love to listen to the brain of the people we try to protect systems against and how you guys approach your attacking. So what I'm going to do is I'm spend a little bit of time running you guys through our PowerBroker Unix Linux solutions as well as our PowerBroker Identity Services solutions. Mainly they're focused on endpoint protection solutions. So when you listen to a number of the attack vectors that were used, can we stop that WordPress was and when I first saw it, I looked, I was like, oh my gosh, that's the current version of WordPress that Jay is actually showing that has it's leaking information. It's telling you information it should not be telling. It should say bad username or password, which means you don't really know, and that would actually thwart an attack that like how Jay was highlighting. But what we focus on is controlling once the user gets on the system. So let's say that a system is breached. What we really want to do is be able to say, I'm not going to allow the user to run certain commands or call certain underlying system binaries as root, for example, or more importantly, I can block those system commands is really what I'm focused on. So in our space, we try to approach the problem solving from multiple ways. One, password management. Two, endpoint protection. And three, the server privilege management, which is kind of the bucket we'll focus in. What PowerBroker Unix Linux does for the system is essentially it's providing privileged command control as well as system level control as to what a user is allowed to do on a system. So it's a very simple deployment. You just load up the deployment console, you discover systems, profile, verify they're ready for the install the systems. If you wanted to use an AD bridge, we can join them to the domain. That way you can simplify authentication. So rather than using local authentication, you're using AD authentication, which makes things a lot easier for you. So with PowerBroker Identity Services, it's really about centralizing authentication so we don't have to deal with thousands of user accounts. Obviously, a stricter password policy, hopefully, when you're managing it within your Active Directory environment. From your user standpoint, they're no longer using dictionary-based passwords, at least hopefully not. Your password policy should protect that. But when the users they have one password to remember versus 10, 15, or 20, so they're likely to use a little bit stronger of a password for gaining access. And obviously, it supports using multi-factor authentication, all that kind of good stuff that you'd really be concerned with. From a Unix Linux standpoint, we're really trying to prevent users from sharing passwords. So a lot of the attacks are about getting access to the root credentials. Once you vault those root credentials and put them in, we're not using a password-based or a dictionary-based password. We're letting a system like PasswordSafe auto-generate a password that it pushes down on that account and it changes it on an ongoing basis. Every day, every week, every month. Password can be 20 characters or it can be 100 characters because again, no human really has to remember it. They just go to the vault, grab it, or automatically get logged on going through the vault. Also, you can lock down your channels of how users gain access to systems. So with a combination of either PowerBroker Unix Linux and PasswordSafe, you could say you're only allowed to SSH in from this IP address range, or we don't allow SSH at all. We'll leverage PowerBroker to initiate commands on a remote system. There's a lot of different ways that you can leverage these products. Ultimately, when you're doing privileged command elevation, you're really focused on control what the user can do, track what the user's doing, and potentially record what the user's doing while they're on the systems. So again, just like our PowerBroker Identity Services trying to centralize authentication, this is centralizing policy management, centralizing all the logs, the recording, so you're not jumping from 1,000 servers to try to figure out what's going on in a large enterprise. It's all being centralized to one location. So that when you're trying to troubleshoot attacks, just as Jay was highlighting, you have one place to go to try to find, identify the data, and then create a plan of attack to protect yourself. So I'm going to jump in a little bit and give you a quick demonstration of our PowerBroker Unix Linux product, if you guys don't mind. So I'll jump on this box and I'll jump on as a demo one. to make life a little easier. And right now I'm just a regular user. If I do an ID command, you can see I'm nobody special. What you just saw was a single sign-on using GSS API and got me onto the box. You can see that I'm a member of the domain users group, which means I've actually logged on using my Active Directory username and password. I didn't have to type my password because of GSS API got me a single sign-on. So from logging onto the Windows desktop as demo1, I'm now logged on to my Linux box as demo1. One user, one account. Disable demo1, I can't get in anywhere, which is huge value add. Now, about commands, if I want to run, pb run, if I could type today, I guess I should have recorded like Jay did. If I type a pb run ID, you'll notice that it submits the command to a policy server. So right now, I'm actually on server 2, but you'll notice that it submits the command to server 1 and says, hey, I'd like to run this command ID, which is really a benign command. But the point is, I'm asking server 1, could you please let me run this command? And the policy dictates that, yes, you can run it. And when we execute that command for you, we'll execute as root. And you'll now notice the difference between the ID command saying that, hey, yeah, you are root now. And I could do the same thing. Let's say pb run, who am I? Let's see what happens here. And you'll see, again, it says I'm root. So what I'll do is I'll say, I'm going to request from the system a root shell. See if I could type in there. Sorry. I think I lost my mouse for a second there. That's really weird. Ah, there we go. Sorry. Lost my mouse just for a second there. I don't know what I clicked on. So we'll just get a root shell here. So now that I'm in my root shell, we'll see that that shell's being recorded, but I'm going to grab that name because we'll do something with that in just a little bit here. But once I'm in a root shell, again, I can run the ID command, and you'll see now it's kind of forgot that I was demo1, and it really just knows that I'm root. But when I run a who am I command, if I could type today, move my mouse, who am I? You'll notice again, it says I'm root. Now what I'll do is, kind of like Jay does, I'll switch over to one of my scripts directory. And you'll see that I have a script called demo.sh. And if I just cat that out, you'll notice that this script is going to kick off. It'll actually echo to the screen that's starting up. It'll actually try to add a user. It'll try to eventually reboot the box. It'll try to cat out the etc password file, all the good stuff that you'd potentially want to do. And again, mostly nothing that's too crazy. However, when I try to run that, what you'll notice is it'll start up. Now, if all went well, again, this is going to reboot the box. It should really never get to that completed line. All we should see is this box going down. But again, I'm still here typing commands. Now, what's happening behind the scenes is PowerBroker is actually jumping in and taking effect. So let's just log in here, and we will. I'm going to log in to server 1 as root. There we go, and I will. I'll switch over and show you the log files. And we'll paste that file in that we recorded. Could I get it right or not? So let's guess I typed in the wrong command there. Apologize. Let's get back in there. So if my demo would work for me really quick here, I'm gonna try to get myself back in there. Let's see. Oh well. All right. So while I am having a little bit of a demo issue, and this is one of the classic reasons why you record, what you would actually see is that PowerBroker quickly blocks certain commands from running. So when I tried to run the command such as rebooting the host, it actually detected trying to run that command. Or when I tried to run the user add command, it picked up that I was attempting to add users, and it just said, no, you're not going to be able to create new users. So no user called root2 will actually exist on this box. So if I were to cat out the etc password file, there's no user called root2 in this file because it didn't allow that user to get created. And that's kind of a lot of the stuff that actually is happening behind the scene with PowerBroker. So what PowerBroker is about is allowing you to gain access to a privileged shell if need be, so that a user can do the activities that they need to do when they get on a host, but not those activities that you don't want them to do, such as rebooting a server or running certain commands. It also allows you to execute commands on a remote system. So if I said, hey, I need to run a set of commands, but I'm on server 2 and I need to run them on server 3, and server 3 is blocking SSH-based access, it'll allow a user from server 2 to issue commands into server 3 that are approved by the policy and then push the results back in. So a user could do system checks, validate things, but only a small subset of commands, so that it prevents an attacker like Jay from jumping from server A to server B, because not only can he run commands on that remote box, but he can run a very finite set of commands that are authorized by policy that we can evaluate. We can force multi-factor authentication. So the first thing I could do is, when I want a root shell, is I could say, yep, you can have a root shell. However, we're going to do a multi-factor auth to validate we should give you access to a root shell. So the main focus of identity services in PowerBroker Unix Linux are two very simple things. One, with identity services, we're talking about allowing you to log on to Unix and Linux with Windows credentials, so making it easier for the user to have to maintain one username, one password, and remember only one thing to get onto all the systems across an enterprise. And with Unix Linux, it's really about, once the user gets onto that system, what do we want to allow them to do? How do we want to control what they want to do? And do we want to put policy around all the things they do and prevent them from doing things that we don't desire them doing? So with that, I'm going to turn it back over to Sarah in just a second here, and because I know Sarah has to jump into
Perfect.
the Q&A, and I want to make sure we respect your time.
Yeah, thanks, Rod. Okay, guys, so let's jump into our poll of the session. You should see that pop up right now. Would you like to schedule a personalized one-on-one demo or conversation with us? I'm going to leave this up. Let's dive into some questions for a few minutes. Rod, this came in for you while you were presenting. Restricting control is great, but teams still need to do their work. Does PowerBroker allow me to run a command like df across, say, 1,000 systems to gather system information? And Rod, make sure you're off mute.
Thank you. That's actually a really good question, and that's exactly what having the PowerBroker agent on all your service allows you to do. Is from one host, you run like the DS command and say, run it on these 90,000 systems and get the results back. We actually had one of our customers leverage that when they were trying to determine what systems were vulnerable for Heartbleed. They were able to do it quicker than a vulnerability team was actually able to scan all the systems by just using the agent that was resident to run remote commands.
Awesome. Okay, Jay, could you have broken that attack path by changing the permissions on the Nmap program, but keeping it set UID?
Yeah, certainly. I mean, that would be, so the Nmap program, nobody knows why that Nmap program was set UID there. And as a defender coming in, I wouldn't want to. My goal is to keep the system working, but to harden it to break attacks. So yeah, I could take that Nmap program and make it only runnable by a group. And one of the things I like to do is basically say, let me create a humans group. Let me create a script that's going to run out of cron that'll go and put all of the users that have a valid shell into that humans group and make sure that they're always there. And then I'm going to take Nmap and all the other programs on the system that are set UID that don't need to be run by, say, the web server, which generally tends to be all of them, or all of them except for something that came with the web application or web server. And I'm just going to make those things not world executable. I'll keep them set UID, but I'll make them executable only by humans. And then I might, for extra credit, go and figure out who actually needs to run that Nmap command and give it a whole different group and make it so that only that group is actually allowed to run it. So I'm always going for least privilege. Good question. Thank you.
Okay, closing down the poll, we'll take a couple more questions before we end the session. Jay, would fail to ban be as effective as OSSec here?
Yeah, so I get that question a lot. Fail to ban takes a very similar approach to OSSec's active response, and fail to ban has kind of a narrower mission, the same way that Tripwire or AID are just file integrity checkers. So OSSec can do active response, and that's one of a bunch of things it can do. Fail to ban basically just does this. It watches log files. It for specific things it knows how to watch for and says, I see too many authentication failures for that service. I'm going to create a firewall rule and have that firewall rule last for a little while. So fail to ban would work here. The biggest reason to use OSSec instead of fail to ban is to use all the other stuff that comes with it, like the rootkit detection, and like all of these kinds of log file watch, all this log file watch and response, because that log file watch and response can do more than just block things. It can also say, oh, you have a system that's running low on disk space. You're probably going to want to handle that before the system, comes crashing to a halt. So yeah, good question. Thank you.
Jay, why did you add the PHP reverse shellcode to the 404.php page rather than creating a new page and navigating to that new page?
Oh, okay, yeah, good question. I honestly chose the 404 page just because it was simple. It was simple and fast. It was just, hey, I'll bring up the editor. Oh, look, first page on the right's 404. Yeah, that feels good. That said, the downside of that would be that if they did have a file integrity checker in place, they would have caught that. The defenders might have caught it that way, and so it might have been smarter to add a PHP page instead that wasn't being watched. Ideally, maybe one of the different location that might not be watched by the file integrity checker. So yeah, I could totally do it that way too. So good question too. Thank you.
I don't know if this is a question for Jay or Rod, but this came in. We use CSF plus LFD in our hosting infrastructure. Would you still recommend OSSec instead?
CS, I'm gonna need to Google that.
Yeah,
so
CSF plus LFD. I don't know what that is.
Okay, so I'm gonna ask whoever sent that question in, do me a favor and toss me an email. jay@inguardians.com works just fine, and I'll make sure that I give you an answer once I can do the Googles.
Perfect, thanks. Okay, guys, we are approaching that time. We need to wrap up. So I received a ton of questions asking about the recording, and yes, you guys will all receive a post-webinar email, and it will contain both links to the recording and the slides shown here today. You'll receive it within 1 to 2 business days from now, so be on the lookout for that. Jay, Rod, thank you guys so much for being here today. A lot of content to cover. I really appreciate it, and always interesting stuff coming out of your presentation. So thanks so much, Jay Beale. And to everybody who attended live today, thank you. Have a wonderful rest of your day. We'll see you at our next webinar. Take care, everybody, and goodbye.